Hey everyone, welcome to Duodecimal Division. My name's Eric Larson and this is a YouTube channel. It's all about base 12 math and specifically base 12 geometry. So this is the introductory video to my YouTube channel. So what I'm going to be doing in this video is just going over the real basics between base 10 and base 12 and really what the difference is. Because it seems that there's an opinion out there floating around that there isn't really any difference between base 12 and base 10 when you really get down to it. So what I'm going to do in this video is explain what the real difference is. So I think the reason that some people think that there is no difference is because we usually focus on counting in ones. You know, we're counting units of whatever it is. So I'm going to use the example of apples in a barrel. And if we were to approach those apples in the barrel from a base 10 perspective, as we started pulling them out and counting how many were in there, we would be counting them in groups of 10. So we would eventually get to a point, say, when there's 81 apples in total. So there would be 8 groups of 10 with 1 apple left over. And that would be the result, and it would be very clear, and that would be the base 10 version. But then somebody approaching that same barrel of apples would start counting, and they would be grouping the apples in groups of 12. And at the end of their counting process, they would have 6 groups of apples, and then there would be 9 left over in the last pile. So they would have 6 times 12, 72 plus 9. So then it's like, okay, it's the same amount of apples, but they have a different number to represent that same amount. And so this is, I think, where the result in our mind comes like, okay, well, it's a different number, but it's still the same amount of apples. So therefore, there's not really any difference. If we were counting, stars in the sky or grains of sand on the beach, sure, we would get different numbers and be able to manipulate them differently, but at the end of the day, it's still the same number. So in this respect, that's right. When you're counting in ones, there's no difference. It's just a different number. But the real difference in between base 10 and base 12 lies not in the counting of ones, but on the other side of the decimal place. It's in the dividing up of the one. When you take an apple out of the barrel and then divide it up from a base 10 perspective, you're going to get 10 small pieces of apple. And then when you approach that same apple from a base 12 perspective, you're going to cut it up and get 12 smaller pieces of apple. So 1/12 of the apple is a smaller unit than 1/10. So the base 10 version of the piece of apple is a bigger sized unit. So when we take that same logic and we approach the Cartesian plane or the XY coordinate plane, we can see that the base 10 version of the plane is a different size unit. The squares are bigger than the base 12 version. So here we have a big square, and we're going to give it the dimensions of 1 by 1. So one side of the square has the value of 1, and then when we divide that square up, I've drawn a line right through the center, and you can see again the base 10 version is larger squares. There's 10 squares along the side. Here the base 12 is smaller squares, and there's 12 squares along the side. So the key point to note here is that the lattice points, the points where those lines are crossing each other, are all different. The closest that we get is the actual center point. This point here is the same, but then right away as we go up the 0.5 line, this point here is a different length from this point, or a different distance from this point down here. So all the rest of the Cartesian plane coordinate points, XY coordinate points, are actual different points. So all the distances in base 12 in terms of the decimals are different. We know the square root of 2 is over 1, then up 1, and then that length here is the square root of 2. So 0.1 and 0.1 results in 0.1 root 2, and that 0.1 root 2 is a smaller unit than 0.1 root 2 in base 10. So that goes for all of the irrational numbers, all the square roots, everything is a slightly different unit. So that's where the real difference lies. And the implications of this, or what happens, is that certain geometric patterns end up having different relationships, or the ratios are different between base 10 and base 12 and the 1. So it really is the relationship between these sized units and the 1 that is different in base 10 and base 12. And what I'm going to be doing in the videos to come, starting with the next one, is I'm going to show you a geometric pattern that has this exact property. In base 10, it's always existed, but it's been floating sort of outside of the 1. And in base 12, it shrinks down and lands precisely on the 1. And I'm going to show you what I mean when I say that, because this geometric pattern then gives us access to the geometry of the circle, which we currently don't have in base 10. In base 10, right now, there's no sort of geometric perfect version of the circle. It's simply not accessible to us, and we don't have that version. We also don't have the ability to divide the circle up into 360 degrees. That might come as a surprise. You might think, well, we do know about 360 degrees, and yes, we do, but there's no geometric pattern, no combination of circles and lines that you can just draw in a given sequence of steps that then generates the full 360 divided circle. And that pattern does exist in base 12, and that's what I'm going to be showing you. I'm going to show you how to use this. It's a type of dodecagon. It's a 12-sided shape. It fits securely on the base 12 grid. And I'm going to show you how we take that pattern and use it to create the diagram that generates all 360 degrees. So that's going to be the first step, the first little journey that we take into the world of base 12. I think that's a good example of the real difference. And I'm going to be able to show you something that's very concrete, a real, provable geometric pattern that it will become the anchor for all that comes afterwards, where we really can see the difference, and that base 12 really is a better form of math and geometry for when we approach the circle, which is in itself a very fundamental aspect of mathematics in itself. So what we're going to be doing again is exploring the geometry of the circle from a base 12 perspective, and we're going to start by dividing up the circle by using a base 12 dodecagon, a geometric pattern that only really works in base 12. So that's where we're going to be going. That's what the next video is going to be, the first step in that journey. I hope you can join me for that. Thanks for watching.